Welcome. Here we're going to be talking about something called margin of error. So when you are taking a sample of a population, we are trying to get a random sample so that our sample will be representative. And the kind of accuracy of that sample is dependent on how large it is. So the more people you ask, the better your odds, the better your accuracy should be. But we understand that it's not perfect. And so we're interested in calculating the margin of error. How off do we expect to be from the true population value, the true population results, based on our sample population answers? So the margin of error is calculated using the following formula. It's plus or minus 1 over the square root of n times 100%. So where n is the number of people surveyed. Or number of data points gathered, whatever. It may not be people surveyed, it may be heights measured or frogs identified, whatever. There's a variety of things that you can do, but it's the number of things that you took data on. But most often this is used when we're looking at survey data, so I like to just say that we're talking about people. So what I do is there's this definition. So we are 95% confident that the true value lies between plus or minus 1 over the square root of n times 100% of the sample value. Now, this 95% is part of the definition. So the 95% is associated with this 1 over square root of n. So this margin of error is for a 95% confident interval. And that means that there's a 95% probability that the true value, so that's what I mean when I say confident, I mean 95% probability that the value lies within plus or minus 1 over square root of n times 100. This is part of the definition. So when you were asked for this one, you were asked for the 95%. You can calculate other confidence intervals, but that is a statistics topic that is beyond the scope of this video. And so we won't be doing that. So we're looking at this 95% confidence interval, and this is the formula we will use. So let's do an example because that will help us. So we have, for example, a survey of US adults. So 1,000 people were asked. Oops. They were asked what activity they most dread. So what are they most afraid of? And 46% said public speaking was the activity they were most afraid of. So I know how many people were asked. That's my N. And I have my sample value. This is my sample value. So I can calculate my margin of error. One divided by 1,000 times 100. When I do that, the square root of 1,000. I'm missing a piece there. Again, you can type this into your calculator. You do 1 divided by, use your square root function, and it'll take the square root of the 1,000. We're multiplying by 100 because we need to get it into percent form because our sample data is given to us in percent form. For the margin of error problems that I do, they'll always be in percent form. We always are looking at that percent. And that's It's a better way of calculating margin of error, in my opinion, because percents are, I think they just make more sense as a way to look at how far away you are from things. Raw numbers don't make as much sense. It's the percents that make more sense to do. So if I plug this into my calculator, I get 3.2%. The percent at the end of this is kind of like my units. I'm carrying them throughout, but I have to have it. So it's 3.2%. That is my margin of error. So if you're asked for margin of error, it's 3.2. Now, you'll notice that in my formula, I had this little plus or minus, and that's what I mean. I'm saying that I'm going to go above and below my sample value, and I'm looking at a range. So there is a 95% probability that between blank and blank percent of the population are afraid of public speaking. Now, I need to find this range. So I need to get the two values that are going to go here. It will be a range, and it will be based on the margin of error that I just calculated. So in order to calculate these two values, what I do is I take my sample value, which was 46%, and I subtract my margin of error, 3.2, which gives me 42.8%. I take the sample value and I also add the 3.2, which gives me 49.2%. So what I'm doing here, that's what's happening with this plus or minus. That's what that means. You do both. You subtract the margin of error and you add the margin of error. And then these two values are the upper and lower, sorry, I should say lower first, lower value and the upper value. So 42.8% and 49.2%. So my sample, 46% said they were afraid. I asked 1,000 people. So I expect I'm going to be off, right? If I'm talking about all of America, which is 330 million people, and I only asked 1,000 people, I can't be 100% accurate. So that's what this 3.2%, that's what this formula is helping me to represent. It's helping me to understand, look, you're asking 1,000 people, which is a drop in the bucket compared to 330 million. Okay, so I have some error, some margin of error. I subtract that from my population, my sample value, and I add it to my sample value. And that gives me the range of values that I expect the true population to be in, the population of the whole country. And it's a 95% probability that between 42.8 and 49.2% of the whole population are afraid of public speaking. So that is what margin of error is, and that is how we calculate it. Thank you for watching. Please let me know if you have any questions.